Hey, welcome to February of the Omaha Astronomical Society's general meeting. Yay! This is a wonderful room. This is one of the newly renovated rooms at UNO. This is room 115. This is kind of where we're going to be for a while, maybe about a year or so. So remember where you parked, and remember where you sit. There's no assigned seating, so don't worry.
Thanks for the signage, whoever did that, by the way.
Yes.
Yeah.
Signs were
Very
hung.
nice.
Chris.
Yay. But we'd all be wandering around the building somewhere.
Yes, if you have headphones, you can use them. But we've seen this before, so on and so forth. Do we have any guests in the room? Oh, hi. How did you hear about us? From her? Well, tell us who you are. Hi, Sophie. Welcome. And
Bridget.
Bridget.
Welcome.
So how did you get excited or interested in astronomy?
I don't know, really. I just like
It's the same for me. You know, it's just one of those. Do you like it? Yeah, it's cool. On my microphone. Is that better? Oh, that's a great room, Mike.
Down deeper.
You want more? You want me to speak? Right.
Let's see what it is, Gary Joe.
Well, welcome. Anybody else in the room? Anybody online who's not been with us before?
Yes,
Yeah, we got a
Austin's
couple.
raising his hand. Austin, you want to unmute?
Can you hear me?
Yes.
Yep.
Yeah, my name is Austin Kucher. I live in Council Bluffs. I'm a professional geotech engineer. I work a lot on the railroad, doing rock and soil instability stuff. Also, I've got a 5-year-old daughter who loves doing Taekwondo. I'm really new to astronomy, but I've had access to a Celestron 9 1/4 for about 20 years, and it's only really just gotten out of the box. Unfortunately, January's been pretty cloudy this week. I got it out a couple times though.
Oh, yes.
Right now, I'm really mostly working on familiarizing myself with, positions of major stars, constellations, and I'd be interested in finding some mentors that can kind of guide me on recording observations, sketching, looking at deep sky objects. So, yeah, I'm looking forward to getting to know everyone at the meetings on Discord and out in the field.
Great. Thank you. Anybody else? Mary. Hi, Mary. How are you?
Hello, can you hear me?
I can hear you. Yes.
Great. Yes, I think I've been a member for a couple of years, but this is my first meeting that I've been able to join. I was actually planning on coming onto campus tonight, but had a long day at work, so
Well, I'm glad you could make it.
thank you.
Anybody else raising their hands remotely? No. Well, for those who are not a member, if you do decide to become a member, you will also become a member of the Astronomical League, which is a national and soon to be international organization of clubs that works together to further astronomy and things like that. They have a quarterly newsletter called the Reflector. It's really nice. It's slick like a magazine. You get access to Astro Park, our observing site in Weeping Water, Nebraska. We do have a telescope loan program. So if you don't have a scope, you can try out a telescope, see what it's like. We have different types. So if you want to have one, what they call a reflector, with the mirrors, or a refractor with glass lenses, things like that, to try to figure out, do I really want to lug this big heavy telescope, or do I want to try out something a little bit smaller and see what I see? We do have a wonderful monthly newsletter, the Stella, which has got a lot of information in it. We do have Discord. There's been a lot of Discord stuff in the past month. It's really pretty neat. And members can vote for motions in the business meeting. Upcoming important dates. Starting in the parks, that's February 14th.
Bring your Valentine to the park. Valentine's under the stars.
Valentine's under the
Well,
sun.
now you know what you can do.
That's right. Although OAS will not be providing dinner. Or movie.
Chocolates.
Or chocolates. The library telescope program is a work day on Saturday, the 18th. No.
I don't think I'll have any telescopes to do, but we'll see.
Should we do it into just a club event with people want to bring their scope to help their scope?
Could be the fix it up for the spring telescope work day, yeah. Telescope tune up.
Yeah, there you
We
go.
got the space.
We got the space, yeah.
It's fun to hang out and get the word out to everybody.
Yeah.
Will there be brisket?
Oh, we may have to work on that a little bit to help.
Mike, could I invite my astronomy Girl Scout club?
We would love the Girl Scout Club come and.
So I've got some families that want.
Sure.
Okay. There you go. It's an in-reach event. Oh, that's a link to the Mizrael groups. The Omaha Astronomical Society, while being in the Astronomical League, there is a regional organization that, so it's kind of like we funnel up through this region to the Astronomical League. So it's called the Mid-States Region of the Astronomical League. We just call it Mizrael, because it's quick and easy to say. They do have a mailing list on groups.io. It varies in its, shall we say, participation. But they do have a yearly convention. Generally, it's in June. And OAS is hosting in 2024. The 2023 event is in Tulsa, Oklahoma.
Date for that?
I want to say the 9th.
That's
correct.
Weekend
9th to
of
11th?
June.
What's that?
9th to the 11th?
The 9th to the 11th, yeah. Because the 8th is a Thursday, for Friday, the 9th, Saturday, the 10th. I was just looking at the calendar today. OAS is a member of the Night Sky Network. There's a bunch of materials and resources on Night Sky Network. We don't really use it to do communication per se, but a lot of people use it to find clubs in their area. So we're on that for that presence. We do have a fan shop. If you click on club information and then click on fan shop, I would ask Mike to model his hoodie, but it is now in Salina, Kansas. Oh, there's one of the t-shirts right there. Carmen has it. So if you want to have OAS swag, that is available. Do we have anybody go to Astro Park in the past month?
Yes, I did.
1, 2. I think I saw somebody else online.
Just raising their hand.
Because they were doing photos earlier this week, so I'm gonna say 3. Did it look okay?
It looked okay, but the road could definitely use some gravel before we start getting some heavy rain because it is barren portions.
Hmm.
And the county is working on 13K heading east from Highway 50. So just be aware if you're driving out that way, there could be some closures or some construction.
We're also working on the road right by the gun club.
They're putting in a new bridge at the gun club. So the old bridge is going away and that road is going to be reprofiled. Which means entry from the city will be going away.
Yeah, you have to go on down.
132nd, go down to 34. Do we know when 13K is going to be finished? That's been going on for 9 months.
I was down there on Wednesday, it was fine.
Really?
Yeah, I was there a week ago and they still had all the construction signs and stuff up. So they must have just wrapped up.
Oh, you talking about the road into town?
Yeah.
Oh, yeah, no, that's been open for, it's been open for a couple months now.
Okay.
It's been, oh, yeah.
All right, then. That's great.
But if they're working
Until they close that,
bridge, then.
the lane to that bridge next to the gun club, that's gonna be. Yeah, keep going south 34. Not one thing, it's another, right?
Still though, our pathway could use some gravel.
Okay.
Yeah.
When we have budget, there's some other things we'd like to do. We can work on discussion of that. Oh, awards chair. Is there an award tonight?
There are awards tonight.
Oh,
plural.
awards, plural?
Plural. Very excited. Down here.
Now, I'm gonna turn my microphone off. Can you still hear me remotely, folks? Just give me a thumbs up.
Yep.
Can you hear Kelly when she talks?
I'm not as loud. Can you hear me
Easily,
easily?
yes.
Oh, nice, excellent.
Love this room. Good mic.
So guys, we have some awards tonight. Yes, excited. So most of you are familiar with Mr. Mike Morrison and how much he has done for our library telescope loan program, as well as outreach all around. And his wife Carmen is also here tonight and supports him and also has outreach hours. So we are so excited. They're part of the club and they have some awards tonight. So Mike has 2 awards. He has an award for the library telescope loan program, or sorry, the library telescope program, I should say. And for also the stellar level of outreach. And so that involves 60 hours of outreach total, including the basic award plus 50 more for the stellar. And he's well on his way to the master level as well. So that's pretty exciting. So we have 2 awards for Mike if he wants to come up. These awards. Now on the stellar level, these unfortunately neither of these come with a pin, which is kind of sad because I love the pins. They're super cool. So Louis is probably going to take our picture. Do you want to hold both of them or do you want me to hold one for you? John was giving me a hard time last month because I held both of Steve's and he said it looks like one of them is yours. So I figured I would ask you. Yeah, and then Louis will. Mr. Oh, here, let me take.
We're gonna.
I present Mike. Megan Carmen as well has an outreach award for also spending some outreach hours, which we so appreciate. And as you guys know, with everything Mike's done with the outreach, as one of the outreach chairs, I mean, outreach is one of the super important things that our club does to reach out to members of the community. We so appreciate that you guys both take part in this and that you take part in it too, supporting him and super excited. So for Carmen, and yours comes with a pin. Ooh. I love the pins. They're well, it's got a little hand and maybe he wants to see it. Carmen,
Can't zoom in that
super
far.
cool. Yeah, no, you definitely see it.
Anybody that wants
You
to see
ask
it should
Carmen.
get their own.
Yeah, there you go.
Yeah.
It's also on the top of the award.
They're right there. Anybody who wants to see it should get their own. So yeah, these are really neat. Do you want an envelope? Sure.
Yeah, we're gonna lose it.
Here, please.
Thank you so much for. Thank you, Carmen. We appreciate you guys so much. I'm glad they finally came after being lost in the mail for a little while there. Would you like a box, by the way? Take these home in. Do you want the box?
Sure, we'll do it. Then you want to-
We have 3, I mean. It's so difficult.
Recycling day on Tuesday.
There you go, there you go. Thank you, guys.
Observing chair. Let me see. Is she online or is Sonali available?
Yes, I'm here. Can you hear me?
Yes, we can hear you.
Okay, so February is an exciting month. It started off with the comet, but Jupiter and Venus really are putting on a wonderful show in the evening, and they're very easily visible. Saturn has its conjunction Feb 16. Some sources I read said 17, so it's really hard to see. It's close to the sun. And if we do outreach on the 14th, you'll be able to find Neptune close to Venus. So there you go. Uranus is still visible in southern Aries, and Mars still is brilliant in the evening sky in Taurus. Mercury is kind of low in the sky, early morning, just in the dawn skies. It goes from about, I think, 10 degrees as usual to even 4 degrees just above the horizon. At the bottom, there are a couple of dates that you can see, some conjunctions on the 21st. Moon, Jupiter, and Venus will form a beautiful trio. The 15th, I guess the 14th, depends on where you look, Venus and Neptune. And as the moon travels along the ecliptic, it passes other planets. So we should be able to see those. Full moon is on the 5th, and the new moon is on the 20th. And of course, the green comet, which has come around in 50,000 years. And, it's been hard to see this because it's been cloudy for so long. But the last 2 nights, I think Wednesday, Thursday, I know Mike and Kim were looking at that too. I did see it Tuesday night as well. It is, if your skies are clear, it's actually not that difficult to see it with binoculars. Just now the moon getting close to full moon is going to wash out a lot of this. But on the 10th and 11th of Feb, it's going to be close to Mars, so actually much easier to find. So let's see how it pans out. That's it.
Thank you, Sonali. Maybe as I close things, my computer will go faster. Oops, you didn't see that. Outreach.
Go for it.
I got a bunch of stuff. We got it.
Here, I'm gonna stop my
Old
screen
business
share.
stuff.
so-
Can I come up there? Oh,
Yeah.
I need words. Well, I guess I want to do some.
Okay,
Okay,
and like here,
yeah.
they'll see it.
And I don't need mic. I'll speak loud. Okay, yeah, I got some like old business as far as outreach. I missed the December meeting and totally forgot about it at the January meeting. But we get some, if anybody's into pins, we got some beautiful pins here. I think Mike gave some of them out at the December party meeting. But if you helped in any way whatsoever with outreach last year, you deserve a pin. So tell you what, let's just set them up here. They're really kind of pretty, I think. What it is it's a representation of the Webb, is it? The Webb mirror on Webb, James Webb Telescope. It says Night Sky Network 2022. Oh, there you go. I'm sorry. Yeah. I keep forgetting.
Spotlight John Larson. And then the camera would be right there. Too close. Or you want me?
So we have
Is it not working?
a lot.
Oh, sorry.
In fact, if you've
There.
helped out with outreach anytime here, come get one. We'll have them out there like, oh, and I'm gonna shove one off. Okay, so I got that.
A little closer, Jeff.
A little closer.
Have that on my screen.
That's a good one.
Good.
Sorry. Hang on. We're getting there.
Oh,
There you
that's
go.
better.
Let me do.
There you go.
Focus that.
Take the
Yeah.
cover off.
It'll fall on the floor.
Poke your eye out.
Oh, they're taped on.
They're taped.
Yeah. All right.
That's really good.
It looks like the JWST.
Night Sky Network Stars 2022. And so if you've helped out with outreach. And you didn't get one. And you didn't get one, if you come to a meeting. We'd love to see your, we're happy that you're with us, but come to a meeting and you can get your your pen also. Now let's do this. How many here helped at Lawrence Gardens this past year? How many got free passes? How many didn't get free passes? I guess I should have, okay. I had a few of those left over too, so.
He'll be right back. folks.
Go ahead, do a little jig.
Yeah. Do a little jig.
We also, not necessarily specifically outreach related, but the IDA recently did a campaign with these T-shirts for Love the Stars. And I made a kind of secondary campaign that tagged onto theirs with our club name on the bottom. And Carmen just launched into the chat on Zoom. Anybody who, and I'll put it in Discord as well. But I just relaunched this campaign because it closed for the next 3 weeks. You can log in, if you buy a shirt, the IDA gets like 9 to a little bit more, depending on if you buy like a hoodie or something more expensive than just a t-shirt. So if anybody else wants to get one of these great shirts with the people and taking pictures of the stars with their cell phones. Log in and buy one. That's it.
And
that's not Cafe Express,
It's
that's
Bonfire.
Bonfire.
They won't,
IDA does all their shirts through Bonfire. They're like limited production.
yeah, and they won't ship until the campaign ends. So if you order it now, it'll be sometime in March, when you'll get your shirt. But they have a few like long sleeve t-shirts, a couple different types of t-shirts. I think they have a hoodie.
I didn't know you could do this, so I had already ordered a shirt. And it was said that it was only available to order for like a day or two. So then Mike had done that modification, so he could run a campaign for a number of days based upon it as well.
And I just did it for a week because I wanted one. So I didn't really extend it out, really advertise it too much, but I think Mark, Cibola.
Yeah.
Bought one as well. So we had two. So we raised like $18 for that first run. So hopefully we can get some more money for the IDA. It's a very nice, comfortable shirt.
Okay, one more thing. There again, I usually do this at either the November or December meeting, but here's some lovely thank yous from the kids with the Papillion La Vista School District. We'll just start them here, pass them around, look at a few of them. Just one around, and then just a few statistics. I hope this agrees with Mike Gallagher, but I'll get to the money later, but let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different schools that we were out there at the Camp Carol Joy hauling last fall. And best estimates, we had maybe 870 kids, and if you count all the teachers and adults, we had close to 960 people that saw something from OAS. So I think that's pretty impressive. And money wise, thanks to some really generous contributions by a couple individuals, the total money taken in was $895. Very generous. Thank you all for helping.
Not a bucket kid.
We'll see about next year. I don't know. But from both of us, thank you very much for making that a very successful.
Anybody who hasn't done, I mean, I know a lot of you who are in here have all done outreach, but anybody online or that wants to get involved, we're always looking for more people to get involved in outreach. It doesn't, take a whole lot of time or effort, and you can, even for like my wife Carmen, you just do a few of them, you can log your hours, you can start getting those certificates and yeah, it's a lot of fun.
And it's pretty simple to write down. It's just like,
Oh, yeah.
but like the number of people you saw, the night.
Yeah, there's a
There's a nice
Excel
spreadsheet.
sheet.
No, it's an Excel
It's
spreadsheet.
an Excel
I've got you. You
but
can email me.
I'm
those if you
sure
want.
Kelly's got it. all there.
I've got one. The one online doesn't.
Yeah.
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 It tells you like what needs to go in there, but doesn't. So I can send it to anybody want if they want it. just let me know.
Well, there's just. It's almost overwhelming now, of course. For a few years with the pandemic, we were really slowed down, but things have just really picked up. Did you want to talk a little bit about last night with Burke or we already talked about it now?
Yeah, I mean, we can.
Or you want
some of those
another
pictures
spot
again,
for that?
But I know this coming year with all the library telescope stuff we've done. Just in the ones around the Omaha area, we're gonna have quite a few extra star parties and things scheduled for those. For anyone who doesn't have a day job, I know there's a lot of libraries that are wanting to do like summer reading program stuff during the day. To have people come out and talk about space and astronomy. That I know I won't be able to get to. So we're always.
I do a lot of them.
Yeah, so I don't want to put it all on John for those, so if anybody has time.
We'll ask for volunteers and
As those come
cry a
up,
lot if we don't get enough volunteers.
as those come up, we'll definitely post for help. Join our Discord. I put a link in the chat earlier for the Discord. If you're not on there, that's a really good resource for us to coordinate outreach events. And let people know if you're gonna be able to come or not. Help us keep track of who's gonna be there and whatnot.
Yeah, I did one of these late afternoon school events last week at Morton Elementary. And I was just blown away. There was about 15 kids. They were 4th and 5th graders. And the questions they were throwing at me was, now I just did a little bit on the planets and the solar system and asked them a few questions and they were just eating it up. So it's a lot of fun.
But yeah, last night we had
I'll let you take it.
70, 80 kids and there were some adults there. They weren't all high schoolers. There were some younger people all the way up through high school. Allison, Kim, Sonali, and I were out there. We got a freezing cold, but we got to observe some stuff out with some of they have some really nice telescopes. They've got a C11 on an AVX mount. They've got 2 10-inch Dobbs and like a whole fleet, like a dozen 80mm Star Sense Explorer refractors. They're all brand new. And they're gonna look for doing more of that stuff and they definitely are gonna want some help with that.
Great. Cool. All right. Thank you. I just didn't have the camera for you.
Oh, look, it's dropping some axes. Be careful. Last it. Saw you, nobody else wants.
I have a membership, so I'd like to give them to somebody to use them. Right. Let's get back here. Yeah, we have the telescope and binocular loan program here. Don't think that I updated my slide with the information, Stanford.
It'll be a surprise.
Yeah. So we can use it just as a reference. As soon as the computer decides. I'm gonna close the bylaws. Take care of it in the break.
Is that like fix it in the mix?
What's that?
Is it like fix it in the mix?
Sounds like we're.
That's right. Apologies, everybody. I do not know what it's doing. Go ahead and speak, Stafford. I'll work on this.
Get you on camera.
Yeah. It's just one more slide. I know I went too far.
There you go.
Yep, I'm gonna make it a little bit bigger. I already clicked it, it's just waiting. And now.
Nice try.
I think I bought a nice computer.
A little bit, so-
Hey, there it comes. Birds here. Okay.
Yes, we did have some activity this month, which is good. The good news, John brought the Coronado telescope back into me.
And the better news is it got checked out again, so. A couple of corrections, both of the refractors are in. I have had a verbal request for the 80 millimeter after the last meeting, but I haven't heard from the individual yet, so it might be either else. The 10-inch stub, it is actually checked out, but not to me. And you got an extension on the 130 SLT, and that's, you'll be on to something total of it this month.
Okay, cool. Thank you, Steph. Program chair.
Hello, how's it going, everyone? Okay, so quick overview for tonight's program. Back in October 2022, a group of 3 gentlemen were awarded the 2022 Nobel Prize in Physics for their each independent research experiments to do with quantum entanglement. And so that program tonight will just be kind of a brief program. Do you want me to talk about some future programs coming up as well?
Sure.
Okay, so what is this? We're in February, so March. I found a gentleman out of New Jersey who had been manufacturing telescopes for the past 20 some years. He focused on Dobsonian types, and his company name was Teeter Telescopes. And then his wife would make the covers for the scopes. So they would kind of sell them as a kit, but I was able to get a hold of him, and he's going to come online, of course, through a Zoom call and talk about his experience, kind of the things that, trade tricks and tips and what he found to optimize those Dobsonian telescopes, and then some things that he's moving forward into now, because he actually retired from that building telescopes just at the end of last year. So he's on to bigger and better things now, but that'd be a pretty cool topic to or have him come on, just because I know so many of you have tried to build your own scopes, or you buy them from kind of small manufacturers like him. And then that's March. April, looking forward to getting a hold of a physics astronomy professor out of the University of Texas. Her and her group of undergraduate and graduate students, they took a set of data from the James Webb telescope observing files, and they actually discovered some spiral barred galaxies out in the distant universe, much what I want to say, much further than we've seen them before. So these are barred spirals that are very, very old, that showed up in the very young early days of the universe. And that's something very new for our standards. So looking forward to getting that group on April. And then either May or June, hoping to hear back from the, what do they call it? Have to thank Mike Motorson for this referral here. What are they called? I was just working on it. It has to do with the NASA learning programs. Why am I not finding it? Oh, it's in my other email. Where they hook astronomical society groups up with NASA speakers, kind of subject matter experts from around the US, which means it could be professors, researchers, people at observatories, and they come on probably Zoom call, and they can give a presentation on any variety of topics. So hoping to hear back from them soon for either our May or June program. Besides that, there's, I think, 3 other people that I've reached out to, and we're kind of setting up sometimes maybe come summer or fall for them to present. And it's a variety of students, someone who's at an observatory, and I forget the third person, but yeah, so some exciting times. And if anyone has a request for a certain program, presentation topic, or they would like to give a presentation, I would love to hear from you as well. So that's all I have right now.
Thank you, Jordan.
Yep.
We have a tool time tonight.
Is it time?
Yeah. Am I surprising you?
I know, I just didn't know when it was going to be.
Okay, I gotta go find it here. Knowing my computer. Okay, let's see, shared with me. Two. Should be the most recent entry.
It's always playing this up. Sonali's heard this already twice. This is just what I gave last night about comments. So it's just a little 10-minute talk that I gave at work last night. It just seemed kind of timely to maybe go over it tonight since comments ETF is up right now. We're hearing about comments a lot in the news.
Hang on a second. Stop my screen share. I know you can still see my screen. Thank you. Strange. It's still updating them. How many people are on the OAS internet that I have shared? Is your video not working?
I don't see it sharing.
Okay, good.
Yeah,
I'm
you're
just trying
not,
to cut
you're
down
not
the bandwidth.
sharing, John. No, you haven't been sharing for a while.
I can get off of it.
Well, I'm trying to get. It's really slow. Yeah. Let's see. I'm gonna close Discord, I'm gonna close photos. Close this, don't need the bylaws. I should slow or speed it up.
I just let, so.
Well. Do you want? Okay, tell you what. I'll work this issue, but for the moment. Allison, you can stay up here.
Okay.
Kim,
Yes.
have you gone around the sun another time?
Yes, that's correct. That's correct.
Oh, well, I'd like to say happy round trip to you. All right. Little birdie told me that there might be something on this table back here. There's some cookies. Yes, indeed.
Some cookies, so I help yourself in the break.
So
Thank
while I fix this, go grab a cookie. We pause the time temporarily. Hang on, folks, we're working on it.
Stretch your legs or?
Recording in progress.
I think
Okay.
one will be sufficient.
I was asked that you should wear a mic.
I would list you both.
Oh, yeah.
I would make you both get.
So this is off.
We're gonna save the trees.
It's email.
It's email.
You're going to be
Only by
okay?
email.
I said if you'd like me to put her on.
Nina, can you hear her?
Switching schools after this year.
Try again.
Allison.
Can you hear me?
It's a temporary email.
No,
No.
that needs to be
Okay,
closer
well,
and louder.
Just trying to make it. So you-
How about now?
That's much better. Thank you.
Better, okay,
Yes, thank you.
so.
Just an
I
email.
will
She would get it too.
It is recording.
Morning, all right, so I was gonna do a brief introduction, I'm Allison. I work for the Lowell Observatory in Flagstaff, Arizona. I moved to Omaha about 5 years ago for my husband's job, but I just continued to work remotely for Lowell, and I joined the astronomy club over the summer. And I study comets, that's what I do for my job. And so last night when Burke needed some people to talk about comets, I volunteered to go do that, and I just put together a little slideshow. Just talk about the basics of comets and then a little bit about comets UTF. And I'll try and go through this quickly, so I don't take up too much of your time. The comet comes from Greek, long-haired star. And then what is a comet? Comets are icy bodies that are comprised of rock, dust, ice, and frozen volatile compounds. These frozen compounds are carbon dioxide, ice, and other compounds that on Earth we might have as a gas. But on a comet, they're frozen as solids. So we have all of these solid frozen compounds. And comets are leftover materials from when our solar system was formed. So when everything was coalescing, some things were left over. And so these comets are these little chunks left over from when our planets and moons and everything was forming in the solar system. They're comprised of a nucleus, which is a rocky center. That's the rocky icy part. And then they also have a coma. When they get closer to the sun, the solar radiation activates the comet. It starts sublimating. These gases come off and it will make a coma. And if we're lucky, we'll also get a nice tail off of it. The greenish colored comets, I just wanted to bring this up because all the news stories with comets ETF right now are like green comet, rare green comet. And it is a rare comet because it hasn't been around in a long time, but all comets are green. They fluoresce CN gas and C2 gases. This is when the sunlight hits them, the molecules break apart, they fluoresce in green. And that's why we see that green color in comets. This is a little schematic I got from a NASA website that has the comet. The main thing I want to point out is that the dust tail and the ion tail are always pointing away from the sun. And so again, that's the solar radiation that's pushing that back behind the nucleus of the comet. These are just some pictures I want to point out with Lovejoy was a very gassy comet. And so it's got that beautiful green coma and a nice ion tail coming out behind it. Hale-Bopp was a very dusty comet. We see the ion tail, which is blue. And then we see that white yellowish tail, that's the dust tail. Dust is, they're larger particles. They reflect sunlight. Our sun is a yellow star. And so that dust tail looks like a whitish yellow. Comets are, when all the planets were forming, they call it kind of planetary billiards, things were moving around. And the comets were scattered to two distinct reservoirs. One is the Oort cloud, which is kind of like a sphere that encloses our solar system. It's very far away. And then the other area where the comets went is the Kuiper belt. And this is kind of along the same plane of the planets out beyond Neptune. That's where Pluto lies. And so those are our main comet reservoirs. In the Oort cloud, that's where we get our new and long period comets. Comet ZTF came from the Oort cloud. And some periodic comets, Halley-type comets, they also come from the Oort cloud. We know this because of their inclination to the plane of our solar system. Our Jupiter family comets come from the Kuiper belt. They're all along a similar plane to our solar system, and we know they're coming in from the Kuiper belt. And so based on their orbits and their angle to the ecliptic, we can infer where which reservoir they came from. And this is just a silly comment that always makes me happy. If you ever read XKCD, these little guys hanging out in the Oort cloud, and then something perturbs them, and then they get thrown into the inner solar system and they start to sublimate. Again, this is just a schematic of a comet's orbit, and the main thing I just want you to take away from this is no matter whether the comet's coming or going, the tail is always pointing away from the sun. So when the comet's actually leaving the solar system, it's looks like it's traveling into its tail because the comet is leaving the solar system and its tail is pointing away from the sun. So both are moving in that direction. And then I just want to talk a little bit about comets ETF. What's in a name? How do we name comets? So you see all these letters and numbers, and I just want to go over what they mean. So C designates that it's either a new or a long period comet. If it's a periodic comet like Comet Halley, it will have a P in front of it. So it'll be P/Halley. So this one we know is a long period comet because of that C designation at the front. 2022 is the year that it was discovered. E means that it was discovered in the 5th half month of 2022. So if we think about it, so if it was first half of January, it'd be A, second half would be B, first half of February, C, last half D, and then E. So we know that it was discovered in early March. And 3 tells us that it was the 3rd comet discovered in that half month. And then last but not least, comets are named after their discoverer. And this one was discovered at the Zwicky Transient Facility. And so that's why we get the ZTF at the end. And so this is the orbit of ZTF. It's a long period comet, has a high eccentricity. Eccentricity is pretty much how squished its oval is. It's got an oval orbit. And so it's really squished. It has a high eccentricity. And that means, again, that we know it's going clear out to the Oort cloud because that its orbital circle has to be really squished. Actually, this is a technical term, right? To get that far out. And this comet has a period of 50,000 years. And it's at a pretty high inclination coming in.
Allison,
Yeah.
how do they measure the number of years?
Yeah, so this is all based on, when these comets first come in, we have to observe them for several months usually. They get discovered a lot of times with these, survey, we can go back and once we know where it is, we can go back and start finding it again. And so we need to orbit over multiple locations in its orbit over multiple days and months. And sometimes we don't really have that orbit refined for several months. And so it's pretty much just measuring where it is and how fast it's moving. And then that can help us finish the shape of that ellipse that it's traveling on.
Thank you.
You're welcome. And so this is a zoom in of ZTS. This is January 12th. This was its perihelion. Perihelion is its closest distance to the sun. And it reached that on January 12th. And so this is just a schematic that shows you where it was relative to the sun and the earth. Its perihelion distance was 102 million miles from the sun, 1.107 astronomical units. And then this shows where it was yesterday at its closest approach to Earth. It was 26 million miles from the Earth and 140 million miles from the sun. So you can see where Earth is relative to the comet. And that's why we've been able to see it really bright these last couple weeks. So this is getting into a little bit of science. The main thing I just wanted, the takeaway here, this is some of my science that I do. I work on the chemical composition of comets. And I made, Sonali kept calling comets little fuzzy cotton balls. And so I made CTF, a fuzzy little yellow cotton ball on my plots. And you'll kind of see that in the middle. And the takeaway with this, I've got C2, which is, we talked about how that's one of the gases that fluoresces in green, and CN also fluoresces in green. So we measure everything relative to OH, so you can get relative proportions of things. OH is a byproduct of water. Water drives activity as comets are coming in closer to the sun. The panel on the left with all the green dots are typical comets. They're ones that are a normal composition. These are our normal comets. And the one on the left is pretty much the same plot, but I colored it differently. And I want to point out that, so on the left, the green is saying that it has a typical chemical composition. On the right, all the highlighted blue comets on there are long period comets. And so the whole point I'm trying to drive home is that it's normal. Chemically, it's exactly what we would expect given where it's coming from in our solar system. So it's normal. It's a perfectly normal comet. And this is another plot with some of the comets I work with, and this is their dust production. The one on the left shows how close it gets to the sun. And you can see it's kind of just in the middle with all the other comets. There's nothing standing out. The plot on the right is how close it gets to Earth. And what you can see is it's clear over towards the left. And that means that it's very close to Earth. And so the reason this comet stands out and is special, and we can see it right now, is because it's so close to Earth. Compared to all the other ones that I have that in my database. So just to review, like what makes a comet great is orbital period. How often does it come close to the sun, and how close does it get? That's going to determine how bright it is. The coma brightness, again, that's kind of relative. Is period, and its composition. How much ice does it have? If it's a really dusty comet, it may not get as bright. And so, what's the composition? What's the proportion of ice and dust on a comet surface? Is going to help us. Nucleoside we know has some sort of importance, but most comets we don't know how big their nucleus is because we can't see it. The only ones we really know, sometimes people get Hubble time that they can try and figure out how big they are, and we send spacecraft up to some of them. We've got, I think, some comets now that have been visited by spacecraft, but otherwise we'll say, oh, it's between 3 and 6 kilometers. We don't really know, and so size does have something to do with it, but it's not the main driver. And this, I saw this last week, but I finally got it today publicly, so I can show you this. This is an image of comet ZTF. through a narrowband band CN filter. And what's cool about this is that we know that it has two main source regions. And so even though from the Earth, we just see the coma, we can use special filters and pretty much do a subtraction, brightness subtraction, get the brightest areas, and we know that it has two corkscrew jets poking out on either side of the nucleus. And this came out on Monday from some of my colleagues. We know that it has an 8.7 hour rotation period, ZTF. They took a series of pictures and they could see these corkscrews changing. And so they saw a repeat and it narrowed its rotation period down to 8.7 hours. And this is a different comet. I don't have the little movie for ZTF, but this is a Jupiter family comet that we measured 2017. And it's just kind of fun. So this is a rotational sequence. So you can see it's different jets turning off and on as it's spinning. And so we have something similar to ZTF. I just don't have that to show you right now. And I'm just going to end here. If anyone has any questions, I'd be happy to answer them, or if we need to move on, that's good too. Yeah.
You think all or most comets are rotating?
Yes. Yeah, they're like little worlds. They have seasons. They all have rotation axis. They're pointed in different directions. When we measure them coming and going, a lot of them are brighter. They're either brighter coming in or brighter going out. Sometimes they peak before perihelion. Sometimes their brightness peaks after perihelion, and that's all depends on the tilt of their axis and where their source regions are. So yeah, they're all little worlds that are rotating on their own axes, doing their little thing up there.
You'd be surprised if they weren't rotating, wouldn't you?
Yeah, yeah. Mhm.
Thank you. Very good.
Was there any other tools comes this evening?
Sure.
Mr. Louis?
Can I share Sonali's photos real quick?
Yeah, just a second, let me. Turn off my screen share. Come on, screen share, turn. Okay, it's off.
These are the photos that Sonali shared at the Burke event last night. Some of her images of comets. That was this comet, ZTF. Right there, Comet Pan Stars. And Comet Leonard. Comet Neowise. Sad I missed that one. Comet Catalina is right there.
Oh,
Sure.
gosh.
If you believe what Sonali's saying, which we probably should.
Yes, you should.
Rutan. See that one? Rutan.
They can't see, well, they can see over there.
And another really nice shot of Neowise. That's beautiful.
I was there for that picture. That was pretty good.
Yeah, nice dark sky.
Yep, that's at Merritt Reservoir with the setting moon. And I also gave a plug for NSB at that talk.
Very good.
We have one more tool time, Louis. Yes. You can see me? Yeah, but people need to be able to hear you.
Yeah, yeah, no, that's fine. I'm happy for them to hear me. Oh, there we go. Hi. All right, so anybody that knows much about me and astronomy knows that I'm a fan of the sun. And we've had some exciting event happen here just a few days ago. January ended, and the average sunspot number for January was 143.6. 143.6 sunspot, the sunspot number for the average for the month of January. The last time that it, the last time that it was close to that was in February of 2014, when the sunspot number was 146.1, just about 2.5 spots higher. And the time before that, it got to 147.2, and that was 20 years ago in November of 2002. So let's oops, how do I move this stuff? John, you went away.
It's a touch screen.
The touch screen, there we go. All right, so just,
It's being a little, it's being touchy, yeah.
there we go. So you can see the sun cycle there. We almost exceeded the entire cycle of the previous cycle. And the peak of the current cycle isn't due until July of 2025. So we are looking, it's going to be, I think, a good cycle. We look at our past a little bit. There we go. We can see that it might get quite a bit, but we're going into a very active time now. The predictions were low, and we had a pretty low cycle last time, but I'm excited about what's coming up. So, thank you.
You're welcome. Okay, now we'll have our official break. Thank you, Louis. We,
I said, what the hell is that? And Carl said, grab it. I grabbed it and pointed at the North Star.
I found it. You ready? Right. Jordan, are you there?
Yes, I'm here.
Ready to rock and roll?
Yep. Forget, how do I? Share screen. Oh, here we go. Alright. Okay. Can everyone hear me okay?
Yes.
Yep. Can everyone see the screen okay? What's up on the screen?
Yeah.
All right. If at any time you can't hear that or hear me or see that, please let me know. Okay, so like I said in the quick overview, back in October 2022, the Nobel Prize in physics was awarded to 3 gentlemen who independently over the past 50 years or so.
Louis said, turn it into a, oh, yeah, yeah.
Do I keep going?
Yes.
Okay, so these 3 gentlemen, researchers, astrophysics, physics researchers, independently did their experiments over the past 50 years or so on this topic of quantum entanglement, which goes all the way back to this debate between Einstein and Bohr, and we'll get to that here in a sec. But basically, they found was the universe isn't necessarily locally real. And we'll get back into that, what that is, and we'll get back to why that's important for all of us, whether we are active researchers, looking at the stars, amateur observers, people working in tech, or just people living on Earth right now or in the universe. So these gentlemen, you see their mugshots here. They've been working on their experiments for, like I said, over 50 years here. And it wasn't just until recently that they were awarded this Nobel Prize. And some of their fellow researchers have since passed away. So they were kind of lucky to live long enough that something like this was finally recognized. These 4 experiments that they did, plus a whole handful of other more recent ones, actually observed a violation in something that's called Bell's theorem. It's a 1964 thought experiment. We're going to get into that. But basically, the meaning of this, our reality must be different from what classical physics, like relativity and that sort of thing, describes. And basically, nature is very weird, and it doesn't always conform to what we think, what we want. So let's jump back to the 1930s.
Australia.
We have Bohr versus Einstein, these two big wigs in the physics community, along with the handful of scientists that followed each side. There were two ways of thinking about particle physics, quantum physics, all the particles, atoms, electrons, photons. There are two ways of thinking about these things back then. And actually, their debates are much more in depth than what we'll hear today. But they're remembered because of their importance to philosophy of science. And since the disagreements and the outcome of this kind of shaped modern physics and modern quantum mechanics, and it's kind of become the prevalent view, forming the root of our modern understanding of physics and possibly everything going forward. And it called attention to this element of quantum theory called quantum non-locality. So you'll hear some terms. We're going to eventually break down all of these. So within this, we have the Einsteinites, the Einstein group. They focused on relativity. They focused on a predetermined universe called a deterministic universe, where everything from the moment the Big Bang happened, it was assigned a name, a color. You rotate this way, you're going to speak this language, that sort of thing. It relies on the conservation of energy, where something's not going to move unless another object or force acts upon it. And these traits and properties, assigned to each particle, they're there and they're going to be there independent of whether we measure this thing or not. So it's like a tree falling in the forest metaphor. The tree falls, it does sound, even though you're not there to hear it. It still makes a sound. So it's very concrete properties. And we'll get into what the realism is and the locality, cause and effect is. The Bohrites, very simply explained right now, these guys were the quantum mechanical physicists, the researchers. They didn't want to assume something had a property unless it was measured, and the things didn't have properties finalized until they were measured. They kind of said it was all just a Schrodinger's cat in the box. It's a toss-up. It is the coin on the heads or the tail side. We don't know until we get there. And they talked about things like the wave function, the probability of the state, where something has the probability to be in 10 different things, but unless we look at it, it's not going to decide what it does. So you actually need to measure something in order to get data from it. All right, so this kind of takes a visual look at what this is, the difference between Einstein's kind of viewpoint and Bohr's viewpoint. If I can get my computer to play. So we have two balls, a white ball and a black ball. We've placed them in boxes, shuffled them around so we don't know which is which. That kind of gets rid of our bias. We keep one on Earth, we send one to the moon. We still don't know which is which until we decide to open the box on Earth. It could be 50% black, 50% white. It turns out to be black, so that we know one on the moon is 100% white. This is kind of Einstein's thing where it was already predetermined what each box was. What the black one was this one, the other one was white. Whereas with Bohr and quantum mechanics, we have no clue what state each of the boxes and the balls will be. It's a 50-50 toss-up. And until we open the box on Earth, we won't find out what the box on the moon is. And once we open the box on the Earth, that automatically determines what color we find on the moon. They're entangled quantumly. So they talk to each other basically. And this does make a difference with experiments and your kind of view of the universe and how you go about measuring things, because it can work with photons, particles of light. It can work with electrons. It can work with different properties of things, how they're made, you know.
Hold on,
different
Jordan.
elements.
We
Yep.
have technical shutdown.
No, no.
Everybody huddle around.
Somebody got to the good part.
That's weird.
Yeah.
Is that on
At
mine?
9, yeah.
I still see it.
Well, you will, but the people in the room,
I can see it.
I can, nobody in the room can, so I can see it. Louis, you have a special computer.
It's like.
Schrodinger's
presentation.
Okay.
There.
Just imagine it in your mind from here on out.
You lost.
Okay, hang on.
Schrodinger's cat, right?
Gordon, can you hear me?
Yes, I can.
Okay,
We're back.
I gotta turn the volume back up.
Yes.
That's what it is, all right. Continue.
Okay, so that's kind of a visual representation of the difference between Einstein's determined view of the universe. The balls are in their solid state already versus Bohr's and the other guy's kind of quantum uncertainty. I can't, there we go. Nope. Okay, so this kind of brings us a little bit to quantum mechanics, just to break this down very quickly, and then we'll get back to some Einstein stuff. In quantum mechanics, first thing is you have this wave particle duality. A light can act as particles. Particles like electrons can interfere like white light waves, and your system, however you have it, can behave as a wave or as a particle, depending on its context. But you can't really predict what it's going to do until you look at it. The second thing, Heisenberg, a really big guy that developed some equations, kind of helping further quantum physics, showed that uncertainty. Oh no, hold on. I'd be kicked off here. What is this? I'm having technical difficulties. Okay, I'm going to keep going. Heisenberg showed that uncertainty, where it's the particle's position in space and its momentum, its velocity, is hardwired into physics, but you can't really know both, one or the other. So once you see where the particle is at, you don't really know how fast it's moving. And once you know how fast it's moving, you have no clue where it's at. The third thing is Bohr, kind of this main guy here on this side, argued that we can only have a probabilistic knowledge of the system. Again, that's Schrodinger's cat. We don't know what's going to go on until it happens. It's kind of like this picture you see here. There's all these different simulations, different ways to organize the hydrogen electrons. Which one? We don't know. We have to observe it first. And the fourth thing is, with this kind of uncertainty, these particles exist in what's known as a wave function. So it's all these possible states that you see. It's not until we measure them that this wave function finally collapses and decides what it wants to do. So we don't know X, we don't know Y, we don't know rotation, etc. And here the fourth thing in quantum mechanics, which is really cool, is particles can become entangled. So particle A is moving along, particle B is also moving along. If they crash into each other, suddenly they start to share the same properties and they talk to each other. So if particle A is rotating clockwise, then particle B is going to rotate counterclockwise to conserve energy, to conserve momentum. So all four of these observations of quantum mechanics challenge the things that Einstein and his group supported, like locality, causality, and determinism. We're going to get to that. So, real quick, he didn't necessarily reject the idea entirely of quantum mechanics, and he didn't that positions in space and time could never be uncertain. He didn't want to really allow this principle to kind of populate itself. He wanted to keep going along the way that he liked. He wanted, with the general relativity, the special relativity, kind of that whole understanding of the universe, and wanted to continue along that deterministic mechanism, which is the universe was made exactly how it's going to be all the way from the Big Bang. Nothing's going to change. Everything is predetermined. So with Einstein, the universe again exists independently of the mind of the observer. That's realism. This is kind of like the notion of object permanence. As a child, you don't realize that when your parent hides their face behind their hands, their face is still there. But as you get older, you start to realize the face is going to still be there behind the hands. It's just temporarily hidden. So it's going to be there no matter whether we see it or not. And particles have definite properties. They've been given to them from the time they were born. So he kind of insisted that quantum mechanics, kind of based off all of this, was either incomplete or just totally wrong. So he sent out to disprove or prove entanglement. They're kind of hoping for both. They want some sort of advancement in science, but based upon kind of where he sat, he wanted to kind of disprove this entanglement where particles talk to each other, where they can interact with each other. And the basis of this EPR paper that he worked on with two other researchers, Podolsky and Rosen, back in 1935. One of the bases of this is localism, which is relativity, meaning a particle or information cannot travel faster than the speed of light, which is kind of the opposite of what entanglement says. Again, entanglement, a single wave function can describe these two particles interacting with each other, no matter the distance between them. I can have a particle here in the Milky Way and another one in the Andromeda Galaxy, and they're going to have the same properties, just like opposite of each other, to balance each other out. And by observing one of them, I automatically know the state of the other one. So it's predictable once that happens. This kind of seems a little counterintuitive, though, from Einstein's point of view. So he had to use realism and localism to get around it. Realism is the particles have to have definite states even when no one is looking. Again, tree falls, it makes a sound even though you're not there. The second part is that localism thing. Nothing can travel faster, even information, than the speed of light. So if I'm in this galaxy down in the bottom left corner and I decide to flip a switch on, it can't instantaneously send a signal to that light bulb over in the galaxy in the upper right corner. It has to take some sort of time. The interaction between me switching the light on has to go to the particle next to me, to the particle next to it, and on and on and on until it reaches that next galaxy. It doesn't just transmit itself instantaneously to the light bulb. So these two things kind of form the basis of Einstein's argument against quantum entanglement, that things can't move faster than light. They're only affected by the local government. And if I change one thing in my galaxy, it doesn't necessarily change the thing in the galaxy next door. So for this, Einstein's finale, his kind of result for this, just to kind of maybe set the problem aside a little bit, but answer his uncertainty and a lot of others at that time, was something called hidden variables. They came up with this thing that even though we might not understand how these things work, there's got to be some sort of hidden properties, hidden information that we just can't yet access. Maybe we don't have the technology, maybe we don't have the equations, the knowledge, whatever it is, we just can't see this information because it's still hidden from us. He didn't want to accept the entanglement theory or anything with quantum mechanics yet. So another like 30 years of speech kind of going back and forth between Bohr's group, Einstein's group, and then finally John Bell kind of had a idea in 1964. There's another thought experiment. There's a lot of thought experiments going on back then. Bell's theorem assumed Einstein's side of locality, which is relativity, can't travel faster than light, and realism, meaning everything's predefined, aka local realism. So with this, he was reading through that EPR paper that Einstein and the other two wrote, and came up with this thought experiment. And it considered whether quantum mechanics gave a complete description of reality or not. And at the heart of this was quantum entanglement. Again, that's when those two particles link up, and no matter how far apart they are from each other in space, their states are linked. So he argued that it was possible to, through experiments, test whether quantum mechanics failed in describing like elements in reality. And so by assuming these two things, he's trying to get the universe to pick a side, basically. Are the hidden variables right? You know, Einstein is correct and there's just something we're missing here. Or is that wave function to do with quantum mechanics real? And we're also missing something over there. So his theory will either agree with this assumption of local realism or it does not. And to do so, he said that some rules must be obeyed and there's a limit that has to be placed on local realism. So eventually there's just too many coincidences in an experiment that say local realism actually doesn't work for us and it has to be quantum mechanics. I'll get into this in just a second. Okay, so this is kind of like the scientific, very confusing way of putting this, but basically Bell's inequality, his theorem, puts a limit on how often the photons will both pass through these sensors and follow the rules of Einstein's universe. There's only so many times that you can have these coincidences show up before Einstein's universe kind of starts to break down and it starts to violate these rules, which means that there's something going on here that's more than just hidden variables. They're basically talking to each other and the information is not predetermined. So if you have a high number of coincidences, then it means the violation of rules, no hidden variables. If you have a low number of coincidences, then Einstein's rules still hold up. It's a little confusing, but we'll kind of go into this here. So Bell, along with another gentleman, Friedman, I believe, they put together an experiment that showed that the predictions of quantum mechanics were actually correct. They sent some photons through some sensors, and they actually showed that these photons were kind of talking to each other, where one photon would come through in say the A formation, A rotation, photon B would come through in the B rotation. If they did this 100 times, maybe 60, 70%, 80% of the time, they matched up, meaning they were like opposite of each other. They were talking to each other. They were entangled. You know, the other 30% of the time, maybe something came up that affected the experiment. And so it turned out that it was actually beyond what classical physics, relativity, Einstein's universe could explain. And so this thing was not due to hidden variables. Some real life proof came up in about another 5 years. Clauser, we heard him at the beginning, could now do experiments with Bell's inequality. And this time he used photons, particles of light, instead of spinning electrons. It's a little bit easier, I think, to use. So he used entangled photons, meaning again, they're talking to each other and they'll behave like a single unit even when they're separated. They'll share the same states, etc. But experiments like this with entangled states are very delicate. It's kind of like if I suddenly start to think, I want particle A to spin clockwise, my thoughts will affect particle A. They have to be manipulated and measured without breaking this delicate correlation, this tie between the particles. And back then, 1972, just a few years after Bell's theorem and his inequalities, you're kind of questioning the status quo. So Clauser and his co-researcher, it was really hard for them to get funding just because a lot of people wanted to still follow Einstein's universe. So it's a quick side note on polarization. In standard quantum mechanics, the polarization of photons kind of looks like this. They're either traveling, like in a vertical line up and down, or they're traveling horizontally across the plane. And then you can actually measure which direction they're traveling, up and down or side to side, using these polarizers. And it's kind of like you have sunglasses that block out certain light from the sun. You probably have polarized sunglasses. If you put two sunglasses together, but one is rotated 90 degrees together, you're going to completely block out all the sun. You won't see a thing. And so these photons have this property called polarization. And the scientists measured this to help them prove or disprove Bell's theorem / Einstein's way of looking at things. So if you have vertically polarized light, so it's traveling up and down as it goes through your field of view, you have a horizontal axis, it's going to cancel all the light out. But if you have a vertical axis, as you see on the bottom in the blue, all the light will pass through. So these experiments were made up of these types of processes. In 1972, Clauser was one of the first people to observe something like this, where he measured these polarizations of light, and he sent two photons in opposite directions to two separate polarizers, like the picture that you see here. What he wanted to see was, could he kind of duplicate Bell's experiment and bring about a lot of coincidences, meaning that these photons were opposite each other, to kind of prove quantum mechanics that they're talking to each other, because it's coming from the same particle, remember? So these photons are entangled. And with his measurements, he actually did find that Bell inequality was violated, which means quantum mechanics was kind of right back then. But his experiment did have some loopholes. These polarizers that you see were already in a fixed position. So he kind of predetermined the setup here when he was doing this, which means his setup, his thoughts could have altered the photons and sent them some sort of information and told them, hey, vibrate vertically instead of horizontally. And quantum measurements should be free and independent of those sorts of influences. So his experiment did have some loopholes. And there's another gentleman 10 years later, but they did say that there's something more here than just hidden variables. Another gentleman, Elaine Aspect, 10 years later, did a similar experiment, but he made it a little bit more complicated, and he closed that loophole of just a predetermined shape or size or orientation of this blue slit here. So what's cool with his, he actually used quartz crystals, where you see those little switches, I want to say, just outside the atom. It's kind of like the light was sent out of the atom, or the photons were sent out of the atom. It hit this quartz crystal, and the crystal was either vibrating or not. And depending on whether it's vibrating or not, it sent the light in different directions. So it's kind of randomized, and a computer generator just randomized the switches back and forth. So that way, the particles of light, these photons, wouldn't have any knowledge of which direction they were going. They're kind of smart. I think they have a mind of their own or something. But they would have no idea which direction they're going until they hit that crystal, and then they would get sent off. And with this, it was similar to the previous experiment, but these quartz actually helped kind of close the loophole and ensure that there's one less way for a scientist to come back and say, there's still some hidden variables here. And he, again, proved that these particles of light, these photons, are talking to each other. These coincidences of particles matching up on opposite sides were just too much, that he also showed that Bell's theorem was violated. However, he still had some, loopholes as well. So what if that computer generator was not random? What if somehow the computer was talking to the photons and give them some top secret information, like, oh, you're going to go this direction when you come out? And there's things like that, and other maybe local hidden variables. So things outside in the room that could affect the photons. There's just all sorts of stuff that you got to be careful for when you're doing these quantum experiments that I can't even imagine how long it took them to set this up. So finally, this third gentleman, Zeilinger, in 1997. So the first two gentlemen were kind of solidifying quantum entanglement and disproving Bell's theorem / Einstein's style of universe. And Zeilinger kind of took it to the real world and he proved quantum teleportation. So if you guys have seen Star Trek, it's not like that. We're not teleporting humans. We don't do it that big, but they're actually teleporting a quantum state from one particle to the next. So if I'm particle A and my quantum state is French, or I speak French, something like that, and my cat is over on the other side of the room, she's particle B, I've automatically transferred my quantum state of French to her via some intermediate particle that is connected to us both. So this was kind of like a foolproof experiment, and he was able to close the loop on the previous two experiments with this 1997 one, and then also with his 2017 experiment, which actually used light from stars to determine the measurements and the observations. So basically, the scientists had no choice of what photons were coming in. The light from the stars had been produced hundreds of million years ago. So if it has something to do, like it was a predetermined setup for the photons, they had no choice. And then the switches here in the experiment were also random. So everything was as random and free-willed and independent as possible, which is a great thing to have for quantum experiments. So Zeilinger kind of used real-world examples, not just inside the lab, to finally solidify this argument that quantum entanglement is real. And he also developed this procedure for entanglement swapping, which in kind of this picture here describes that a little bit, where it's 4 particles total, and they basically can all start talking to each other because you have 2 sets of particles. And once one particle talks to another particle, they kind of get together. And if you have these 2 particles that act as one, another 2 particles that act as one, and they all start talking to each other, it's kind of like this huge chain reaction where huge groups of particles can start swapping information. How this applies to the real world is really, 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 really cool. So this Zeilinger researcher and a Chinese team with a Chinese satellite back in 2016 actually beamed pairs of photons to 2 different labs in China that were separated like more than 1,000 kilometers apart. And the information they sent in the photons, this entanglement survived the journey, which has been pretty impressive. And to take this one step further, in Austria, they distributed pairs of particles across the Eurasian continent. And in these particles, they had a particle, say, in France, and then a particle in, I don't know, Uzbekistan. And particle in France has some quantum key, some really important information in it that they want to transmit to Uzbekistan. With this quantum key and this long distance entanglement, basically that equals an unbreakable cryptography and top secret messages. Like, as a person who loved playing spy as a kid, if I could use quantum particles to transmit like a top secret message across the world or the universe, that is super cool. And if someone tries to break in to the secret message, then particle A suddenly tells its researcher, hey, alert, someone's breaking in, and it resets the whole message and gets rid of all of it. So this sort of thing can really be applied to kind of a real world setting. It doesn't mean that Einstein's version of the universe is totally dead. There are ways that that locality and the realism can still be, possible. And those things there are kind of other experiences that people have. But the opportunity for a quantum future where we have quantum computers that can even more rapidly transmit huge amounts of information across the world, from us to the Voyager satellites back and forth. It improves our physical measurements of everything to do small particles to galactic size things. We can build quantum networks, and even, talking across the world and these encrypted communications. It's kind of an impressive thing what we're going to learn about this quantum world can achieve. So if you would like to watch a few more YouTube videos that really explain some of those final things further, I highly suggest these last 3 ones. It's incredible what finding more about this quantum world can do for us in just real life. So that's all I have for tonight. Thank you for your attention and listening. I hope you enjoyed it and learned something cool about our quantum future. The end.
Pardon, can you hear me from the back of the room?
Yep.
Wow, that's a great sound system. I'm changing the lights. I'm going all the way back.
If I lost it in there, I apologize. I lost myself a few times too. My state is undetermined.
Oh,
No one was thinking I had a virtual question.
was there a question in the chat? Okay, nope. No questions in the room?
If you were using this for, say, spacecraft communications, then what would you have to do to be able to maintain that entanglement over a long period of time to then enable this communication?
I think kind of the main things it was touched upon in some of the researchers' experiments was getting rid of those sort of loopholes and sources of, I think, outside influence that could maybe change the data that's going from, say, particle A to particle B. If you're talking from the Earth to your satellite, there could be a lot of interference and influence, or someone trying to hack in. Other things that you might want to watch out for long term. I mean, there's all sorts of things that could, in physics and other particle wise, that could affect maybe the particles themselves, whether it be, I don't know, they're hit by a solar wave, some alien race decides to intercept them and send them back. I don't know how that worked. Say long term. I'm not quite sure for other things for long term. I just know of what they encountered for their difficulties in these experiments. It'd be kind of interesting to see how we could use it for the Voyager missions, if that's even possible. But we're getting more information about it. So I don't know, it's something to look forward to. That's a really good question. Sorry, I can't answer it that well.
Thank you.
Say, if you could answer that, you'd be very rich.
Exactly. All right, you guys are my inspiration then.
Okay. Thanks, Jordan.
My pleasure.
Right. Let's see. Oop, that's not what I'm looking for. Okay, we did hear back from Leonard. He said they've collected their first data. Everything went amazing and they're gonna review it and see what they got. So live reports from the field. Look at that.
Real science.
Real science.
Yes. I need to find the Stella. The minutes, because we are now in the business portion of the meeting. If you've not seen a recent article about light pollution, the numbers look not that great. That at least 10% brighter every year.
Wow.
Wow.
Yeah, it was 17.
It's kind of scary what's happening.
You want to share that?
Oh, yeah, I should share that. Sorry. Thank you. I mean, just because we're switching to LEDs to save energy, it doesn't necessarily mean we have to have them at 100% brightness all the time.
Yep.
4,000, 5,000 degrees.
So how do I encourage the elementary school in this behind my house to not have their lights pointed upward?
Well, the IDA has some handouts that you could give them. Cause by having the lights on, it's actually making it easier for people to do things around their building if they don't want them to. I mean, one thing a criminal wants to do is be able to see what they're doing. If there were no lights and they had a flashlight, would you be able to tell there was somebody there?
Yeah. But so far I haven't been able to convince them of the,
Well,
You got a BB gun?
That would be going to
Right.
go forward.
Sledgehammer.
Yeah.
School itself would not be. able
tell
to
them that they're wasting money by leaving their lights on all night.
so far the only
And you
response I've
can't
gotten back
sleep.
is, oh, it's for security.
It
you know, kind
shines
of
in
a
your yard,
general.
in your windows and you
Right.
can't sleep.
So my house is higher than the school, yet I've got like 3 of their lights pointing at the back of my house. And I just asked them, could you put covers on your lights? And so far, no.
Light trespass.
Yes, that reminds me of a.
It's for light trespassing. You can go to the city.
Put some
Yeah.
crowds on
No,
the.
there you go.
They can make them put some
Can
trout
you
on.
do that for the streetlights?
Yes.
Oh, good, cause I could do some in my street. I need some. All right, let's see.
And the church lights?
Minutes. We had our meeting on January 6th at 7:30. There were 1 person guest and 3 new members. 2 people used Astor Park in December. We talked about starting in the park, which I believe was plotted out that week. We talked about library telescope program workday. The usual things. Kelly gave an awards update. Steve earned his 2 Astronomical Leagues awards. Yay. Signed an observation about quantritids in the comet, which we have been seeing this week. And there was a presentation by Mike on outreach. Stafford report on the telescope loan program. There's a tool time by John Johnson. Used Sky Safari. Talked about white dwarf stars. Jordan gave a program about astrophysics PhD candidate Rose Waugh from the University of St. Andrews, Scotland. We had our business meeting where we read the minutes, like I'm doing now. Treasurer's report. And let's see. No report from Astor Park because Stephen have done there. We had old business of telescope fleet and mineral bylaws. We did talk extensively about the mineral bylaws and they are being voted on as I speak at this moment. They have all been done. It was a series of extra 2-hour meetings over 3 weeks in January to get that done. Budget was approved and put in, and then we close this business meeting. Is there a motion to accept the minutes as read?
Yes.
Nina. Steve seconded. Motion has been made and seconded to accept the minutes as read. All those in favor say aye.
Aye.
Opposed? It's aye.
Yeah, I have it.
Okay, treasurer's report.
Do you want to read it?
Do you want me to read it?
Sure.
Okay. It was $273.51 in dues. There was a $50 donation for $323.51 income. Expenditures was $77.17 for the domain renewal, which included our email forwards. With an account balance of $15,254.82 at the end of the month. Which was Tuesday. Any other items on that?
No.
No? Okay.
Well, I did head down to the bottom. Let's see. I've been adding that there are 3 new members, we welcome 3 new members and 5 members, their memberships expired.
Oh, that's right. Okay. Vice President.
I went to Astro Park, last week. Road is, showing some wear, it will need new gravel, everything else looked good otherwise. And, other than that, I was the only person who logged in, but apparently two other people came after me for a total of 3 for January.
Okay,
So that's my report.
cool. Thanks, you. Old business. Telescope fleet. We wanna,
Yeah, I did a little, I will call it an unscientific poll of Astro Mart and cloudy nights. I think we had an item a while back where I was tasked to look at some prices and values. The light switch is kind of a hard one to pin down for an 8-inch because I found 5 total ads on Astro Mart for the light switch. They were for a 6-inch model. And they're running roughly $650 if working. There were 3 actual listings for entire telescopes. There were 5 listings altogether. The other 2 were for pieces and parts. Because these have an unfortunate characteristic of if you blow the firmware load, it completely fries the board. So I was just gonna leave it at that. Now, the 2080 is kind of an interesting one. That's for I'd say a median price for those runs about the $400 to $600 range. That is, if they have the silver coated mirrors like ours has. I did some further research too on whether it would be feasible to get that replaced and have two functioning Schmitz. The good news on that is it looks like, unlike a lot of the older Celestrons, these are not as dependent upon aluminum foil or rubber as alignment shims or spacers. So I'm reinvestigating that. I got a ballpark price from Terry Osterhowski to get that secondary recoded. It looks like it's about $70 to $90. So I'm gonna re-examine doing that because it's a nice scope and the web sphere seems to indicate that if you can get that silver coating off and a good aluminum coating on it, we have ourselves a pretty nice little scope. It has some electronics on it, but they really don't work because we're missing some pieces and parts. It was donated to us without them, so. We had one individual a while ago check it out, and this person was quite favorable about it, but I've looked through it and you can definitely tell there's some challenges. So going forward, Mike, you gonna bring up that topic we were discussing in the board with what was that scope you were looking at?
The night of work?
Yeah,
Which
the one that you said projected images instead of.
oh, the
Oh,
EV scope.
the EV scope.
Yeah,
Yeah, I brought one tonight as an example.
you did.
Yeah, it's in my car.
So
Oh.
if anybody wants to
Maybe we should look at that after the meeting real quick.
step out in the
I
parking
can do
lot.
it as maybe a tool time next week if you want.
But what I was gonna throw at the club here is if you're wanting an interesting outreach scope. And you decide not to go with that, consider giving a light switch a whirl with one of those cameras that you can put in the eyepiece portion so that you could project.
EAA, yeah.
Yeah, so I'll throw that thought before going forward with trying to determine what a value is, like. If I had to ballpark it now, I'd say probably about $650 to $800 for that scope, because it is actually working pretty well. Well, the last time I used it, maybe I should say. So you have a resource if you decide that's interesting to you.
Okay. So would you say that we can continue to do the research and we'll revisit again?
Yes, I just wanted to, it sounded like we had kind of an open tasking to deliver some numbers and. He says I found them as the 8th of January.
Okay. Great.
That 9 1/4.
Oh, yeah,
Yeah, I thought we had agreed that was gonna be a loaner to.
there's been a little bit of movement in the last week on it.
So the Luminarium, does not at this time feel like they're able to take that on as part of their programming. But in talking with Alan Wong, from Prairie STEM, which is, becoming quite a large organization, they do, kind of like a lot of what John used to do for AIM, STEM, they go to the schools, they do STEM education, VR, robotics, programming, esports, so they have a wide range of programs that they do. One thing that they're gonna start doing is developing all these STEM kits that they're gonna be pushing out into schools. So I've been talking to him about kind of creating some STEM kits based around the library telescopes. And at that point, we would need to create some curriculum or partner with them, create some curriculum, grade specific for the different age levels that they'll be doing it. But they also have a couple of facilities, including one down at the Mastercraft building downtown. And he indicated that he would be more than happy to house that. It's the 9 1/4 on the AVX mount with the Star Sense. And house that down.
And there was talk about doing events.
And then, yeah, we would do, you know, outreach there, programming, whatever, and you know, help, it would remain the property of OAS. It would just be on loan to Prairie STEM. And
Great.
live in their building down there, and then we could, you know, haul it out to do observations and, you know, we talked about getting and they would probably buy that part, but getting a camera, getting a Stellar Made or something to do, or a laptop with Sharp Cap or whatever to do some EAA and to be able to, you know, have that on screen
And for those who don't know,
There's some cool
EAA
stuff
is electronically assisted astronomy.
So you're projecting what you see through the eyepiece to a screen, so everybody can view it all at once. You can live stack in real time so that you can get really, you know, detailed images of deep sky objects, not just a faint fuzzy, but actually pull out
A little bit of color.
structure and color and
Well, that sounds cool.
Would this be used downtown?
it would be used downtown.
I don't know what you could see that from downtown.
Well,
With the live stacking, you'd probably be surprised how much.
Really?
Yeah, because with the Star Sense, you know, it does plate stalling automatically. So it knows where it's at, and then with the Sharp Cap live stacking software, you would do plate stacking there as well. Like A-Stap or whatever, there's some different programs for that. And then it's also a 9 1/4, so you can.
that's what we're thinking, since it's a bigger
With a
aperture.
focal reducer and then, you know, pull in a lot of photons and you just build up. Like you would for normal astrophotography, except instead of post-processing it all at, you know, the day after, you're doing it kind of in real time.
Processing,
Yeah,
essentially
Yeah.
live. It's probably a filter that'll filter out this city lights anyway, right?
Some of
you
it.
could get
except
you could get a city light
LED.
filter, an ultra high contrast filter. You know, if you want to look at like emission nebulas, you could get an oxygen 3 filter, try some different stuff like that, but. Anyways,
Sounds great.
so I don't know what the process.
The only thing I think that we would probably add to that would be like a set of wheelie bars now, so it can be rolled out.
Yeah, like scope buggy.
John's trying to remember
Trying
something.
to remember. There's that old telescope setting in that, but you didn't get the wheelie bars with it, did you?
Which, the one
The
that's. in my
broken one,
office?
yeah.
No,
No.
I don't know whether there were.
Krista,
bars with
I
that.
mean,
No.
do you have any wheelie bars in any of your scopes? That you could roll up?
What I did is I snagged, I think it's, piano.
All right, there's other solutions to it, but
Yeah. I don't have any for mine scopes.
okay,
couple of
I'm trying to remember the
casters.
there was the telescope that was down at Papillion that got tipped over and broke.
Okay.
It had a wheelie bar, but I don't know whatever. Yeah, I did.
I didn't remember, I don't remember ever
We didn't
seeing.
get that.
You didn't
far.
get it. They probably just threw it away.
We got the tripods,
Yeah.
and I still have that, and I still have the scope and all that.
Please got the map.
Yeah.
Sorry, Andy, but
Yeah.
No, just something to think about.
the wheelie bars, yeah, they're.
No, that would, and
Is
you know what?
Doug?
They would even probably have the resources to,
No, what was the guy that was taught astronomy down at Papillion?
Oh, Doug Schultz.
Schultz,
Yeah.
I got one myself.
he would know.
I think that they were.
Carla asked the question, what is a wheelie bar? It is essentially putting wheels on your tripod so that you can roll your
Roll it
telescope
around.
out of the garage and set it up.
And set it
Like
up.
it has, generally on the outside of the wheels, there's little pins that you
Yeah.
spin that will raise up off the wheels so it stays put
Into level.
and to make to level, yes.
That scope had a.
So it's
wheelie bar.
kind of handy to, because most scopes don't have wheels. I'd say majority of scopes don't have
I
wheels.
got one I'm gonna sell.
Maybe we didn't
I
get
got a
to
scope
talk
I get, I'm gonna sell.
Yeah.
Let's-
But I want the money.
So,
Prairie
I mean,
Stem
it's a
pro-
good
They
opportunity.
probably would have the resources to supply that.
Yeah, they did.
I think GMI made a lot of.
Yeah,
They're not the only one, though.
Scope luggage is $325 now.
Yeah,
Those
you
are
get
more expensive.
Or a couple of.
We can-
A piece of plywood,
on
a
it.
couple 2x4s and 3 casters and you're in business.
I just bought a furniture, probably does the same thing.
That's what
Yeah.
I use, is piano mover.
I have a scope levy, but I use it for my 16, so. Need that otherwise.
Anyway.
Thoughts? I just wanted to put that out.
Okay.
I mean, we're not making a decision.
Yeah.
Yet,
They have more,
but
more,
the
dis-
opportunity is there. I mean, we're gonna have to come up with the curriculum plan, things like that. I mean,
More-
we've got a lot of curriculum resources.
more discussion needs to be had with them.
With them.
Yeah,
At that point in time, I told him that the Luminarium had first dibs. And he just expressed that he would be more than happy to work something out with us if that fell through. That has fallen through, so I'm gonna get back with Alan at some point. And with the blessing of the group, I'll continue those.
I think it's a great idea and I think you should pursue it.
Pursue it.
sounds great.
Okay.
I don't
Awesome.
think that needs to be a motion, does it?
No,
Okay, thank you.
we're not
Not until
deciding.
it's
We're just
final.
pursuing opportunities.
Yes.
I mean, working in that field,
Mm-hmm.
we have worked with Prairie Stem before from my time with AIM. And it was always a good collegiate working together, kind of working towards the same goals. They actually have a robot dog and a whole bunch of other pretty cool stuff.
And it'd be nice if there's enough information with our name on it
Oh, yeah.
and membership
Yeah.
information, so.
They get a lot of grants.
Yes, I was gonna say they've got.
But I mean, you know, if people are interested in astronomy and they come at it through there, it'd be nice for them to know we exist and that we have meetings.
Because if they
and
have
can
these
join
kits that they're
us.
handing out,
Yeah,
I mean, you know,
I-
it should say Prairie Stem and.
yes.
Oh, yes. So,
Yeah,
I
they're,
think they do target more K6.
yeah,
they're.
but you gotta
You gotta start
get,
somewhere.
you gotta inspire them when they're young.
Yeah, he was
Absolutely.
pretty interested in an EV scope as well. And then on some of their older kids doing. Like creating
Well, they've got a lot of
like
free
3D, like
robotics.
3D printed telescopes. You can 3D print a telescope. You can 3D print a full go-to telescope. You can make
Wow.
a go-to mount out of Lego Tech Tricks or whatever. And he was really into a lot of that stuff, plus some VR astronomy stuff that we're looking at doing, so.
You can do a lot of operating robotic telescopes too. Free.
Like programming and stuff, all of that stuff he was very excited about, because astronomy is a gateway science. So you know, you can branch off and do engineering and math and chemistry and all these different things from astronomy and just use that as the spark too. So that was my approach with him and he seemed very interested.
Okay. Great.
And John, you got a text from Carol in there about a donation
Carol has a,
with a phone number. It's in the chat.
Carla,
Oh, sorry.
I picked up I think, a telescope carrying case with handles that I would like to donate. Who do I contact? Just gathering dust at my house. Okay. Cool. Let me write that down.
Did it down.
Along my line.
Yeah, even the geo, if it's.
Okay.
used, yeah.
Be somebody close by too.
It is, that's 556 number. Probably Northwest Omaha.
All right, just because there's gonna be two entries on the new business, don't look at the number two. We're gonna look at number one. Because I forgot to take it off. We haven't fully ratified that part yet. That was a long discussion, but
Let's table that.
that's table. Number two is table. Do we need to vote? Okay.
No, we need.
Okay, Misrule 2024 planning.
10 minutes.
We got 10 minutes. Let's take 5 for this. Let's hoping to have more. We need to have a committee at some point for Misrule. I'm assuming I'll be on it. Nina will be on it.
I'd probably be on it.
Mike,
I'll be on it.
Bill, Steve.
I will decline at this time.
Anybody? Anybody else?
Okay.
Sorry.
Ellen? Who else was that?
Oh, I'll be on it. You put me down. You need some. People that have been through it before, right, Bill? I've never actually been to a Misrule.
I hadn't I'm either. sitting the same and I way, planned it.
And it was terrific.
And it was
It was
great. We
absolutely-
did great.
They still talk about it in.
And you know what?
Good.
We actually had live streamed interviews at our Misrule. Guess who did the interviewing?
Yeah.
If you want to see some me being a nervous interviewer, I'll give you the links.
That's.
I think you did a good job.
Yeah, it's, oh, thank you. It's on YouTube.
Yeah.
You interviewed me, I think.
Possibly.
Yeah. I had to resurrect my colander talk again, you know.
So if you do not know, the Mid-States region of the Astronomical League has a conference every year. At last year's conference in St. Louis, they were asking for people for 2023. I put my hand up and I said, I'll do 2024. Because I wanted 2 years to prepare. But because we were doing our 60th anniversary dinner plan, which was enough time to deal with. So after we kind of did preliminary look at locations, we thought we would replicate what we did in 2013. So Mahoney, possibly doing stuff at the SAC Museum. We've got a pretty good inn at the SAC Museum. So kind of replicating that structure. And that's coming up. We have to at least do the reservation in June. Because you can't reserve it earlier than a year out.
You need to start having meetings.
Yes.
Yeah, you need to check the AO webpage. They've got a great guide for how to do that. We're probably behind time already.
Yes.
They say at least 18 months, I think.
This year's is in Tulsa.
Yes.
I don't know if I will be able to go, my work schedule. But there is no virtual component.
Yeah.
There is plans in the bylaws to have a virtual one if a in-person falls through.
So is it the Tulsa Club or is it Walkers?
It's the Tulsa Club.
Tulsa Club's gonna do it, I guess. Okay.
Peggy's on her way to the Winter Star Party. Hence the voting has been done on the bylaws.
Oh, okay, now just, yeah, because we've tried twice to have it down there.
Mhm.
That was always Broken Arrow. Well, they have their separate little club in Broken Arrow.
Yeah,
Oh, the club.
it's a, we can get into that story.
You looking for new topics from new business? Still in new business?
Yes.
Messier Marathon.
Oh, yeah. You know, we actually did discuss that at the board meeting, along with a number of things. We actually had dates that we had planned. I want to say it was
March 13th or somewhere in there.
No, it was like 18th, I think.
whatever the weekend is.
March 18th is
St.
Patrick's Day-ish. It was either gonna be the 18th or the 25th.
Fifth, if you're looking at Saturday.
Yeah. Well, you're gonna see the whole list now. Everything I was writing down. So. Yeah, Messier Marathon was either gonna be the 18th or the 25th. But yes, we would like to do it. More information. March. At least we have the dates, we can say in the Stella so that it's in the March Stella for the March event. It's not ideal. Just because there's other things on here, there is the Metro Science and Engineering Fair in March. So there'll probably be, we'll be looking for people to be a judge.
Yeah.
Has it? Does it go out?
An interest form did.
Tuesday, April 11th, there's National Geographic live tickets. Oh. Astronomy Day is April 29th. Earth Day is April 22nd. The Mahoney Star Parties start again in April, is that correct?
May.
Very good.
May?
Yeah.
Okay,
May through September.
birthday's in Elmwood Park on the 22nd.
that's my understanding, yes. I believe it was already on their website. Our discussion was, do we do a separate astronomy day in addition to Earth Day? Because it's the following week. There's a lot of push, Astronomical League, all these other organizations push for that too.
Is there a good reason to do that? We've never done it
I don't,
before. We've
I don't
always
know.
coordinated with Earth Day.
With Earth Day,
yeah,
be able to reach more people. We could do a sidewalk astronomy the next week.
And to make our outreach that much easier on everybody.
Yeah,
So,
that would work.
Library Telescope Program is pushing for people to do stuff on Astronomy Day.
That would work if we.
Yeah,
did
we
this.
could, if we coordinated with the libraries, that would be good.
Oh, there you go. That sounds good.
On the
So-
29th, the moon will be 70% illuminated.
Especially if they're advertising it, promoting it.
Oh, moon observation.
there's other
Yeah.
things to do besides just the one telescope.
Okay, so yes, Messier Marathon. 18th. 25th. I'd say both. If one group wants to go to the 18th, one group wants to go to the 25th, or the weather's bad on the 18th.
We usually set up 2 days for
Yeah.
that reason.
So. Do we need to do a motion for that? I mean, it's normally just
No.
outreach stuff, right?
Schedule.
So it's just
It's just a
discussion.
Workday. At Astro Park,
Hadn't thought of that.
why I'm here.
Come up with a date.
Full moons this next few months are gonna be the day after our meeting. So that might be rough for,
March
Some
might be too
people.
early. April probably the best.
it's still. If we have on 7th, the full moon is on the 8th.
Right.
First. Just throwing it out there.
Yeah, minute and a half. Motion.
I moved. to-
No, let's think about this.
I moved to close the meeting.
Second.
Mike. Moderson.
Are you calling for a motion to close?
It's 10 o'clock.
So moved.
All those
If
in
nobody
favor?
else has.
A motion has been made and seconded to adjourn the business. Be all in favor, say aye.
Aye. No.
Outside.
Overruled.
Is to talk about. Never.
Make sure you